Hi, my name is Rahman Khan. I'm going to teach you how to use Minitab by taking you through a worked example from my book, Minitab Exercises for Greenbelts. By the way, that's available on Amazon. I recommend you work along with the example by downloading the dataset from my website, RMK Six Sigma, and by the way, that's free. All the details are given below. Let's go when you're ready. So this video will show a worked example of sequential design of experiment within the assistant. I suggest you work along by downloading the datasets from my website RMK Six Sigma. Now the full Greenbelt course is available at thinksixsigma.com. So this is example 11.25 from the multifarious section within my book. It's actually the last example of the book, and I like it because it explores the wonders of nature. Now sequential DOE examples are going to be quite long. In fact, within this example there are 6 sets of tasks to complete. So what we'll do is we'll do the intro to the example and then we'll look at each set of tasks in turn. Did you know that kilo for kilo spider web is stronger than steel? In theory it could even stop a bullet, with the second graph showing you that it's tougher than Kevlar. The thread is actually stored in the spider's spinning gland as a liquid containing many different proteins. The thread becomes a solid as it is drawn or pulled out of the spider's body. Depending on the proteins used and how they are aligned, spiders can make up to 7 different types of threads with different properties. Processes like ion exchange and separation of proteins by laminar flow result in different types of thread. You are working with a team of researchers who want to copy this phenomenon and make artificial web. Your task is to establish which features are important to the strength of the web produced and what levels of the features would give the maximum response. Also report on the questions given within each stage. Task 1. Generate the screening DOE template. So number 1, starting with a new Minitab project file, your task is to produce the screening DOE template and give it to the research team so they can gather the response data. You have been requested to generate the screening design with 24 runs. Then number 2, save the template in Minitab as a project file called web.mpx. It's good to save your files. We can lose our templates sometimes and it just saves you having to type in everything again. So now I'm going to go through the factors in this study, given the full factor name, the shortcut for the name, the low setting and the high setting. So protein concentration post ion exchange is going to be called protein, low level of 3, high level of 10. Then we have draw speed of the web, which is going to be called draw S, low level of 4, high level of 12. Reynolds number of the liquid flow times 100 is just going to be called Rn, low level 5, high level 25. Shearing force in spinning duct, SF, low level 5, high level 100. pH of liquid in spinning duct, the short name for that is going to be pH, low level 2, high level 10. Water content of liquid in spinning duct, weight percentage, is going to be called WC, low level 10, high level 25. Methyl group content of liquid in spinning duct, weight percentage is going to be called methyl, low level 5, high level 50. Amine group content of liquid in spinning duct, weight percentage is going to be called amine, low level 2, high level 20. So there are 8 factors altogether. The required name of the response column is strength, and that is the measured strength of the web produced under these conditions in our chemical process. Who knew that making spider web was so complicated? So next time you see a spider web in your house, just think about the chemical processes that are going on to make that spider web. Let's start by opening Minitab. There's no datasets to download because the first task is to produce the DOE screening sheet that we're going to give to the researchers. They're then going to complete the response data on for each run and then give it back to us for analysis. So let's create that DOE worksheet. So I'm going to click on Assistant, DOE, Plan and Create. And from there we know we're going to create a screening design. So let's click on that. Okay, so this is the menu for create screening design within the assistant. It's going to create a Plackett-Berman design. So we're kind of locked into that. That's the lack of versatility within the assistant. You're locked down into the Plackett-Berman design. My response is called strength. I had 8 factors. Just bear with me as I type in the factors and you can do the same as well. Okay, those are our 8 factors, and we said we were going to have 24 runs, and that means that you can look for smaller effects within your analysis. Click OK to produce the worksheet. And the next task is to save that. Let's just have a quick look at the experimental worksheet that we've produced. So column C13 is strength, where we expect the researchers to record the response data for each one of these 24 experimental runs. Column C2 is the order that they are going to run the experiments. And you'll see column C1 is randomized for everyone, and that is the standard order that the experiments would have been run if they had not been randomized. But like I've said, everyone should have a different run order, or at least 1 in 24 people will have a different run order from each other. What we are expecting the researchers to do for run 1 is to set up their machine with a protein of 3, draw speed of 4, Reynolds number of 5, shearing force of 5, etc., and conduct that experimental run in the machine, make the thread, test the strength of the thread, write down the number here, and they're going to do that 24 times for each one of these runs. And that's the stage that comes next. Now we are on to task 2, which is analyze the screening DOE, because we've given our DOE worksheet to the researchers, and the research team have gathered the response data from the trials. The DOE template and response data is now in worksheet 25, web screening. Now what we have to do is follow along for tasks 3, 4 and 5. Just follow me as I do those tasks. And then we have to complete the following tasks and answer the questions. So number 6 is analyze the screening DOE. Number 7, at the screening stage, which factors are significant? Number 8, are there any issues with the residuals? And number 9, should the DOE proceed to the modelling stage? So maybe that's some advice for the researchers. Should we proceed or not? And the only reason you wouldn't proceed if you didn't find any significant factors. Okay, now we have to load the data in. So I want you to do steps 3, 4 and 5 with me, please. And because everyone's going to have randomized data, we need to get around that as well. So what I'm going to ask you to do is highlight from column C, row 1 to column 12, row 24, and delete that data. Then hopefully you've downloaded the correct spreadsheet, which is 11 multifarious questions. And what we need in there, and there's quite a lot of worksheets, you see, there's a lot of work that's been done in making those examples for you. We need to go to number 25, web screening. So click on that. And what we need to do there is copy all the data, including the response data, from cells A2 to M25. So highlight that, Control C to copy, go back to Minitab and paste that in column C1, row 1, and it should align correctly. Yep, I'm happy with that. Don't know why the spacing's gone a bit funny, but that's okay. So now I've got my response data in, and everyone's data should be the same. We can now proceed and analyze the screening DOE. So now I'm going to click Assistant, DOE, Analyze and Interpret. And the only box that's highlighted for me is to fit screening model. So I'm going to click on that. And it says to me, do I want to fit the screening model? Yep, that's why I pressed the button. So I've done number 6, analyze the screening DOE. Now it's asking me at the screening stage, which factors are significant. So when I look on the summary report on the top left, it's telling me that shearing force, water content, protein, Reynolds number, and methyl content are all significant. pH, amine, and draw speed are not significant to the response strength. Then it's asking me, are there any issues with the residuals? So that's really asking me to validate the model now. The diagnostic report shows the residuals, and when I look at the residuals versus fitted values plot, there are no large residuals. There are no patterns of the type described here. So that's okay. When we look at the residuals versus observation order, well, we have to remember that I sorted the data, so that is no longer applicable. However, these residuals do validate the study. Next, I'm being asked, should the DOE proceed to the modelling stage? Yes, it should, because it found 5 factors that were significant. Now we're on to task 3, which is generate the modelling DOE template. So number 10, do not change the factor levels. The goal of the DOE is to maximize the response strength. Number 11, make the modeling template with 2 replicates. That should produce a template with 38 runs. So we're going to do what we did before with the screening DOE, but this time it's the modeling DOE. We're going to create another template and we're going to give that to the researchers. They're going to conduct each run, get a response value for us, and then we're going to have to analyze that. But this step is create the modeling template. Let's do that now. So here we are back in Minitab. This is the analysis of the screening model. Now there's 2 ways I can produce the modeling DOE. I can go to the top and just say, click on that button saying create modeling design. Or I could go through the menus again. Let's just use the button because it's there. And it's saying to me set new factor levels. Remember I said we don't want new factor levels, so I'm going to click on no. And again I'm given the option to change the response name, so I'll do that. I'll change that to strength. And my goal is to maximize the response. It's already got my 5 significant factors loaded in with the existing levels, and number of replicates I've said we're going to have 2, and this is to be able to detect smaller effects, and the total number of runs in my DO is going to be 38. Right, I'm happy with that. Click OK to create the modeling template, and there's my DOE modeling template with 38 runs. Everyone's DOEs are randomized on the standard order column. But anyway, we give the DOE template to the research team. That brings us to task 4, analyze the modeling DOE. So the research team have taken our template and they gather the response data. They return the completed modeling DOE template to us as an Excel sheet, and that's 25 web modeling. So that contains all the response data. Now what we have to do, if you follow along to steps 12, 13 and 14, after that we have to analyze the modeling DOE and then answer the question at the modeling stage, which factors are significant. And then number 17, were any significant interactions identified? Then number 18, which factor has the greatest effect on the response? And then answer number 19, which is what are the suggested settings to achieve the maximum response? What is the prediction interval for the target response? And remember that strength. And then 20, just to validate the model on the residuals. So let's first transfer the data into Minitab, completing steps 12, 13 and 14. So I go back to the Minitab modeling sheet. I highlight all the data and delete it. Then I go to the Excel worksheet 25 web modeling. Click on that. Then I take all the data there. Don't need to take the header columns, including the response data. There should be 38 rows. I select all of that, copy it, go back to Minitab and paste it in. So now standard order is no longer randomized and we have our response data. We're now ready to analyze the modeling DOE. So I'll click Assistant, DOE, Analyze and Interpret, and this time it's asking me to fit linear model. I'm going to click on that. And it says, what's your goal? It was to maximize the response strength, and it's still the same, so I'm going to click OK. Now we're on step 16. At the modeling stage, which factors are significant? And when we look at the summary report, the 5 main factors that we had are still significant. Number 17 says, were any significant interactions identified? So there's only one significant interaction that's been identified. AC, which is protein shearing force. Then number 18, which factor has the greatest effect on the response? So when you look at the main effects plots, I would say it's between shearing force and water content. And we'd have to dive in a bit. So let's have a look. Axis label 5, 398 to 725. So that's about 327 difference. 422 to 700. Yeah, so when you actually look at the numbers, then shearing force is the factor which is having the most effect on the response. What are the suggested settings to achieve the maximum response? What is the prediction interval for the target response? Okay, we need to have a look at the prediction and optimization report for that. So the predicted maximum strength is 1232. with a prediction interval of 962 to 1503. The settings to achieve that are given here. Protein 10, Reynolds number 5 times 100, so it's 5,000, sharing force of 100, water content of 25, methyl content of 50. So number 20, are there any issues with the residuals? We need to have a look at the diagnostic report for that. There appears to be one large residual, which is a fair way from the main body of data, so that could be an issue. But because there's only one, we'll let it go. I don't see any unusual shapes. And remember, again, we sorted the data, so the residuals versus observation order is kind of not relevant here. But I would validate this model based on the residuals. I would be wary of that one, and I would check the results again. Number 21, should the DOE proceed to the response stage? And that's kind of a critical question because it could involve a lot of work for the team. So let's have a look. So in the report card, we're given one of the subsections is curvature, and this tells us whether to add additional points on or not. And Minitab is saying Minitab did not detect any evidence of curvature in your data. When curvature exists, the average response at the center points is either higher or lower than the average response at the corner cube points. A linear model may adequately describe the relationship between the response and the factors. Minitab is not advising that we add extra points into this study. But you know what? Sometimes Minitab can be wrong. So task 5, generate the response surface DOE template. And step 22 is add 13 additional points to model curvature. So let's do that now. So click Assistant DOE, Analyze and Interpret. And this time we go to add points for curvature. Minitab is asking us, do we want to add 13 additional points to model curvature? We say yes, we do. If we check on the worksheet, there are now lines 39 to 51, which are the suggested 13 additional runs that we should conduct to check for curvature. So we then pass this worksheet with the additional runs on it to the research team so they can conduct those runs. Now we're on to task 6, analyze the response surface DOE. So the research team took our template. They conducted the 13 additional runs, they analysed the strength of the material, they then gave us back a worksheet called 25 WebRS, which contains the response data. Now what we have to do, you're going to follow along as I copy that data into Minitab. Then we're going to analyse the response surface DOE. Then we're going to answer the question, were any significant quadratic terms identified? Remember, Minitab advises us not to have a look for additional terms. Then 28, what are the suggested settings to achieve the target response? What is the prediction interval for the target response? Then we're going to answer the question, were there any issues with the residuals, which is basically asking, do the residuals validate this model? And then 30 is an interesting one. Use the assistant's regression routine to generate the regression equation for the response surface DOE. Unfortunately, for some reason, the response to surface DOE does not give us the equations that it generates to find the maximum solution for us. So we have to use the assistant's regression routine. So the first step, so we can all analyze the same data, is to highlight all the data, not the title row in Minitab, select it, and then delete it. We then go over to Excel where we've got the data for this exercise. Find the worksheet 25 WebRS, which contains 51 rows of data, so it's got the 13 additional points to find curvature in there. Select all the data, remember not the title row, copy it, take it over to Minitab and paste it in there. Okay, so now we should have all the same data based on the standard order. Now we can analyze the response surface DOE. Click on Assistant, DOE, Analyze and Interpret, and this time we want to fit the quadratic model. What's your goal? Yep, we want to maximize the response. Question 27, were any significant quadratic terms identified? Let's have a look at the summary report again. The first thing to note is the 5 factors that were significant in the modelling DOE are still significant. The AC interaction term that was significant in the modelling DOE is still significant. But we also have another interaction term that's become significant now, that's AB. And DD, which is water content, is now a significant quadratic term. So the model has changed quite a bit. Now 28, what are the suggested settings to achieve the target response? What is the prediction interval for the target response? For that we go to the prediction and optimization report. So the target response is now 1216 and the prediction interval is 979 to 1452, and the settings to achieve that are protein 10, Reynolds number 500, shearing force 100, water content 25, methyl content 50. 29, are there any issues with the residuals? Well, now we have 3 data points with large residuals. There was only one before, but I suppose now we've got 51 data points, we are going to have some more. But again, I would be wary of this one, which is like quite far out from the normal data, and we should investigate that one. But I would validate the study on these residuals once I had studied this point again. Number 30, use the assistance regression routine to generate the regression equation for the response surface DOE. Well, we're lucky we only have 5 significant predictors and 1 response. So Minitab's multiple regression routine within the assistant can handle that. So we click on assistant regression, optimize response. So response variable is strength. We want to maximize the response. We can enter our 5 continuous factors, and there's no categorical factor. Click OK. So what you need to be sure of now is that Minitab has formed the same model for both. There's a couple of ways of doing that. One is to look at the R squared, so it's 86.14 on the regression model. In the DOE model it's 86.14 as well. Now we've got to make sure that each model has the same terms. So the 5 factors have got to be significant. The protein shearing force interaction's got to be there, and the protein Reynolds number interaction's got to be there, and the water content quadratic's got to be there. So when we look in the regression routine, so we've got the 5 factors that are significant. We've got the water content quadratic. We've got the protein Reynolds number interaction. We've got the protein shearing force quadratic as well. Great. And the last thing that we can do to check that they are the same is have a look at the residuals. So let's just look at the residual that's really far out. Okay, so that's row 34. It has a fit of 504.84. When we look at the multiple regression routine residuals, it's row 34 with a fit of 504.84. So I'm pretty sure it's using the same equations and the same solution for this problem. But now we can have a look at the final model equation, and it's given here. Shame we don't get that in the DOE. Right, that completes this DOE question. I hope you enjoyed that and learned a lot from that. If you want to learn a lot more about Minitab, come over to thinksixsigma.com and do the full course there. See you next time. If you want to learn more about Minitab, you can subscribe to one of my many courses on my new website, thinksixsigma.com. You can also pick up a free 365-page Six Sigma Green Belt guide from my website, thinksixsigma.com. Let's continue to learn together. See you soon.